To start with, there are only 3 or 4 styles of proportions that you're going to see. Anybody remember what this style was called?
Angle bisector.
Good. If you don't have that written down, please write it down. If you have it written down, memorize it. Angle bisector proportion. What does that mean?
Angles are 2 angles are equal.
If we have 2 angles that are equal, you're looking at an angle bisector. Extend the bisector a little bit, and that shows you what you should put into the proportion. Since 4 and x are on this side, since 2 and 5 are on this side, put it on that side of the proportion. What did x turn out to be? 10. I'm assuming you know how to solve a proportion, how to cross multiply, etc. Number 2 does not have an angle bisector in it. And you should have corresponding sides proportion written down. The only way you can get corresponding sides is if you divide up your triangles. That's the big triangle, that's the small triangle. If you have question marks, put in a variable. Put in a variable. Put in a variable. Notice what I'm doing with the x and the 12. What operation? Addition. Some people are writing down multiplication. Make sure you write addition. The small triangle has 12 and 8. We're being told that this length here is 12. That gives me a proportion that's 12 over 8. And then x plus 12 over 12. Mistakes we're seeing. Some people have already taken this test. They're multiplying 8 times x, and then they're forgetting about 8 times 12. Show the actual multiplication on another line. Give yourself an extra line, then you won't forget to do the distribution. And from that, x turns out to be 6. So, tell me what we're doing in number 5. Which type of proportion? Oops, I jumped ahead. Number 3. Would you do an angle bisector proportion, or would you separate the triangles? Separate the triangles. I'm not going to actually finish it. But does everybody understand where the 32 came from?
No.
Yes.
From what? 12 plus 20. This is definitely 72. I need this length right here. If the whole length is 72, and this portion is the x, how do I find the portion that's left? How do you do anything if you're trying to find what's left?
The low.
I heard somebody say.
The low what?
Did somebody say subtract?
The low enough.
Yes.
Over here, we were adding things together to get the side. To get that little side, I have to do a little bit of subtraction. That goes right here. Can you see now what you're corresponding? You're corresponding 32 with 20. You you are corresponding 72 with this. If you do the cross multiplication and work for that, you will get 27. At the end, you'll have some time to look over your workbook work that I have assigned. If you don't understand or can't get from this to this, come up to my desk, we'll take a look at it. I'm going to leave this alone and just write an answer. X equals 25 for number 4. If you go back and you find that you don't know how these answers are being done or resulting in these answers, that's what Tuesday is for. We're going to have some time where I show you a few little problems, but the rest of the time is going to be you asking questions. If there's something on here, after we've gone over all 26 questions that you still don't understand, that's for Tuesday or at the end of today's class. What kind of proportion? Is it corresponding sides or an angle bisector proportion?
Angle.
Angle bisector. Extend the angle bisector, and then just use what's below it or to the left as one part of the proportion. The other part, that one turned out to be x equal to 8. Number 6, what would you like to do? Either the angle bisector proportion or the corresponding sides?
Corresponding side.
Corresponding sides. If you do corresponding sides, it will work. But I can also do a shortcut with this one. You can only do the shortcut with the non-parallel sides. So this piece, this piece, this piece, and this piece. If I've got all 4 of those, I don't have to divide up into triangles if I don't want to. I can just do this. I take the pieces of that side, make a fraction. I take the pieces of this side, make a fraction. And that will give me the same answer as separating. I can only do this if I'm not looking at the parallel stuff. If I'm trying to find a parallel piece, then I've got to separate it like I did right up here with the 2 triangles for number 2. It's up to you. Some people prefer to just deal with the corresponding sides and divide up the triangles. Some people like using the shortcut when they can. This one turns out to be x equal to 4. For the people who were here when we went over 7 and 8, what was the answer to 7 and 8? Are they similar?
Yes.
Both of them were similar. Can you tell me why? If we're not looking at triangles, what are we looking at? Angles and sides. So I gotta know, are the angles the same? Are these angles the same as these angles? Yes. Are these angles the same as these? So that worked. Then I got to check the sides. The sides have to be proportional. They're not going to be the same numbers, but if you make fractions with corresponding pieces, they should be the same. What's 12 over 16 as a decimal? Use your calculator. You don't have to do lowest terms.
75?
0.75. And they're all equal. Because they're all equal, we can check that off too. And that's why we wrote down yes and yes, because 5 over 2.5 was the same as 10 over 5, which is the same as 14 over 7. It's all 2 over 1. If any of these are different, then it's not similar. Page 2. we set up proportions because things were similar. Actually, this one, we were just looking for a scale factor. Did we have 2/5 for that one?
Yeah.
Where did that come from? Well, you could look at 14 and 35.
Fake first part.
Make sure you reduce. If you're finding a scale factor, make sure you reduce. How come I put the small one on the top? Because the big one was first in the drawing. Because it told me to. Make sure you read your directions. Sometimes these questions are as simple as reading what's in front of you. This one wants an actual, whoops, skip number 10. Number 10 turned out to be 5/6. If you have question marks, put in a variable. X/6, 10/5, X turned out to be 12. X/6. 30/5.4. That X turned out to be 36. How do I know that that makes sense for number 12? What's the biggest side in the little triangle down here? 6. So this number we're looking for should be the biggest side in the larger one. Is 36 the biggest side in this figure? Yes, because you got 30 and 32.4. So at least it makes sense. If you got something less than these two numbers, then it wouldn't make sense. For some of these problems, some of the information didn't show up in the triangles. So if you don't see an arc here and here, put that in. If you don't see an arc here and here, put that in. I can't remember if I told you guys to put that in. Why am I allowed to do this? Write it down. Vertical angles. Don't forget everything you've learned up until this point. They're telling us it's similar, so you can jump to the proportion right away. 14x/30, 98/70. As long as you're consistent, this goes with this. This side goes with this side. Just be consistent when you're making your fractions. When you're doing your actual work, that should turn out to be true. Same with this one. 9x minus 5 corresponds to the 21. 84 corresponds to 36. Let's do this one. How do you solve a proportion? Cross multiply. 21 times 84. 36 times 9x minus 5. Some people skip these steps. I recommend you write it down. You're going to have all periods. You're going to have an hour and a half. The review problems are super easy this time. You're going to get through that right away. It's just a matter of going through. People with calculators, what is 21 times 84? 1764. And how about 36 times 9? Is that 324?
Yeah.
But that's got an X next to it. 36 times 5. Is that 180? Tell me what to do. If I've got a two-step equation, how do I solve that? Add the 180. Now I've got 324x equal to 1944. Final step. Are we getting 6 out of all that? For the classes that have already taken this test, some of the questions want you to find x. I think that's what this one did. But some of the questions want you to give a side length or give an angle measure. Sometimes you're going to have to put it back into your algebraic expression. Is my arithmetic right? Do I get a 6 out of that? Next page. Circle the word if and similar. Those previous problems told us they were similar. Now we've got triangles and we've got to figure out if they're similar. Write those 3 things at the top. AA similarity, SAS similarity, SSS similarity. Those are your only choices. So what is always an option? Not similar. Write that down. That's a possibility. You are allowed to put in vertical angles. So let's put those in everywhere that we see them. See it down here. 1, 2, 3, 4. 1, 2, 3, 4. So I'm allowed to put in the vertical angles. Make a guess. If you were looking at number 15, which of those might it be? What are these things and what's that thing in the middle? It might be side angle side, but you have to check and see if it's proportional. Always go with small to small, large to large. 10 is small. What else is small in the other triangle? 22. So I got to look at 10 over 22. What is that as a decimal? Use your calculator. What's that as a decimal? 0.45. What is 13 over 28 pretty close to? 0.46. If they're not exactly the same, not similar. Redraw. Small, large. That's great. I figured out that I've got 2 sides, but there's nothing over there that's SS. I gotta either have another side or another angle. Where's the other side or the other angle coming in? What's the same about the little triangle and the small triangle? Put an arc there. Is angle U at the top of the small one and the top of the large one?
Yeah.
So now looking at these components, what do you have? Side angle side. This one, they didn't turn out to be equal. They turned out to be not equal. This one, they all turned out to be 1/2. So now I can write for UTS, UQR. Make sure they're in the proper order. Just like with congruency, we want similarity to be consistent and corresponding. So what's a possibility for number 17? Maybe SAS? It is SAS. And triangle. RST goes with REF. '18 is definitely not SAS. What is it? It's AA. And triangle EFG would be ESR. You'll notice for 19, I put in a lot of arcs there because it's different. It's different than angle C. It's different than T. It's different than S. And those already had 1 arc, 2 arcs, 3 arcs. If I actually put numbers in here, it might look something like this. 50, 60, 70. That has to be the same as that. This is different than anything else, so maybe that's 40. If you have that, do you have any of those 3? This is not similar. We don't have enough things that are equal. All we have are this angle and this angle. What's an option for 20? SAS, and it turns out to be true. So we got KLM, T, U, V. You still have to test it. I'm not testing number 20. I'm assuming that you know to test out that 13/65 is the same as 12/60, which is the same as 1/5. Is that right? Next page. We're being told now that things already are similar. I don't have to prove anything. I can jump right into the work, but something's missing here. Can you see that these 2 letters are the same? So put that in. Put an arc there, put an arc there. Put 2 here and 2 here. Some of the arcs did not show up on the final copy. That's the way that should look. And this one should look like that. Put one on the U, put one on the H. Since we're being told it's similar, we can jump right to the proportion. 91 goes with 52. 98 goes with 8x. X turns out to be 7. Same here. I know the 16 goes with the 8, the 28 with x plus 8. If you're having trouble getting from the proportion to this, come and see me at the end of class or ask a question on Tuesday. All right, 23 and 24. What is the What's the key thing that you have to add to what's going on here if you start seeing ratios? What do you have to introduce to the problem or put in the problem? All right, you start with a picture. So what's the picture in both of these cases? Triangle. We'll start with that. You should also circle some key words. This one is angles. What's this one? Sides. So some stuff goes inside, some stuff goes on the outside. If it's angles, inside or outside? Inside. Am I going to put 3, 4, and 5 inside?
No.
What should I be putting? 3x, 4x, 5x. That's what you got to introduce. Write that down. Introduce a variable. Every problem's different. The mistakes we're seeing on the test, people are doing the first one correctly. They're saying a triangle adds up to 180, so they're doing this. That's great. And they're figuring out that x is
15.
how much? 15? And then they're stopping. What does the question want? So what else do you have to do sometimes?
Substitute.
What's the smallest angle? So I'm going to put that right there. What's 3 times 15?
45.
So I need to sometimes do some substitution, put that back into the problem. Other people are doing this. They're seeing, okay, this is 7, 5, and 3, and they're doing this. Is this right? If you're dealing with sides? We're dealing with sides, so we don't want that. Where should those numbers go? Outside. Sides. Outside. Are those going to add up to 180?
Yeah. Wait. No.
No, because they're not angles. These are angles, that's not angles. So don't take your sides and add them up to angles. What do these add up to?
38.
How do I know I'm supposed to add?
Perimeter.
Perimeter. If it said area, I would multiply. But it's saying perimeter, I know I add the sides up. They're telling me it's 150. That's what I put over here. So same style of equation, but different numbers, depending on whether you're looking at angles, sides, or whatever's involved. That x turned out to be, what do we have here, 10? Is that right? That doesn't seem right. What do we have here, 15x? Oh, that's right. But what's being asked for? What's the longest side?
7.
So take that 10, put it back in. What is 7 times 10? 70. That's your actual answer. That's your actual answer. If you just write down what x is, you're going to get partial credit. Geometric means. I'm going to show it to you in a slightly different way than I may have before. Maybe this will help you remember better. And let's see, Josh and a few other people. If you're planning on taking the higher level course next year, just work on that. Okay, going home? Early dismissal? Look for videos over the weekend, Trey, for all the stuff that we've done up until this point. What's x times x? Right, that's the mistake. Gina just said 2x. What's x times x?
X times x is x squared.
X squared. And that's fixable. You're at least cross multiplying. X times x is x squared. What's 4 times 9?
36.
How do you get rid of, just in the main office. Yep. How do you get rid of it? How do you get rid of that little 2? What's the square root of 36? 6. We're interested in the positive one because it's geometric mean. Take a look at your notes. Did I tell you there were 2 steps to this? What were the 2 steps? Well, that's what I'm showing you now. There's the multiplication. There's the square root. I may not have shown you the actual proportion, but that's where it's coming from. I told you to take 5 and 20 and multiply them. Then I told you to do the square root. That's why you did the square root, because this is actually the true definition of geometric mean. Yes.
For us to get it correct, do we have to write that? Like
No.
the whole.
How you get your answers up to you on tests. On a quiz, I might have you. Whatever works for you. On Tuesday, we will do extra problems that are maybe just a little bit more difficult for these. But do you think you can do the problems I just showed you? That's a big chunk of the test. Is there space someplace in your notebook, blank sheet? Actually, I've got extras. I'll give you guys some paper today. We're going to put the test blueprint right on here. Stay with us, Sherry.
You do it on your head.
On the top.
Right,
Get
test
it
blueprint at
there.
the top.
No, because you got to be distracted
swear,
and
I
rub
swear.
it on. Where is it at?
Like right here.
Don't be getting mad, girl. Try to help you out.
All right, then get it. Y'all been talking about it.
8 of them.
Yeah.
That's all
I
right.
got gray hair. Oh my god.
This other one is like, can't actually get it.
What is it? That's because my mom.
Who wasn't here last class?
Let me see, alright, can I get it?
If you pull them out, there's just gonna be more.
I told my mom.
Make sure after we do the blueprint, I'll give you what that you missed last time.
Oh,